everybody. In this video we're going to be talking just a little bit about ratios and how they appear on the SAT. As a quick review of what is a ratio, remember a ratio is a comparison of one part of a substance compared to the other. So for example, if I was to sketch, let's see here, let's just take the circle here, and let's suppose that I split that circle into two different regions. Let's say I did something like so. So this is region 1. I'll sketch it in blue. Well, kind of went outside the lines there, but hopefully it's okay. And then the other region, let's say, is in purple. And both of those regions represented a different thing. Let's call the blue region, let's say the blue region represents, I don't know, a number of marshmallows. Marshmallows in a box of Lucky Charms, and which, to my mind, the ratio should be flipped. It should be the purple. That would be that proportion. Nevertheless, I wasn't consulted when marketing decisions were done. Anyway, so let's say blue represents the number of marshmallows, and the purple represents the number of, I guess, what is it, the oat cereal or whatever cardboard type tasting thing they do there. Okay. Well, let's just review over what this means. If we're doing a ratio, what we're doing is comparing how many marshmallows we have to how much oat cereal we have. And it's usually written as a fraction. So let's say I could do, let's put this in red. Let's say it was for every 2 ounces of marshmallows, there were 6 ounces of the oat cereal. So we would say something like this. The ratio would be, and it could be written a couple of different ways. We express each one of these. But one way would be, we could say it's 2 marshmallows. I'm going to put 2M for marshmallows. Over every, 6 ounces of oat cereal. So I'll put 6O, which looks kind of like a 0 there. So actually, let me do a different variable. How about we'll just put C for cereal. Okay, so there's a ratio. Okay, but another way that I could write this ratio, because again, remember, all a ratio is doing is comparing how much we have of one thing compared to how much we have of the other. Unlike a fraction, the order doesn't matter. This could be the same thing as I could have said we had 6 ounces of cereal for every 2 ounces of marshmallows. Now, in the world of fractions, these would be completely different things, right? Because this is 2 over 6, this is 6 over 2. Those are different numbers. But again, a ratio is just a comparison. It's comparing how much I have of one thing versus how much I have of the other thing. And the order in which you stack them does not matter. Okay? The other way that ratios are sometimes written, but this is not as helpful in terms of solving these problems on the SAT, is something like this. I could say for every 2 marshmallows, ... I have 6 ounces of cereal. Or, likewise, I could say for every 6 ounces of cereal, ... I have 2 ounces of marshmallows. These two things, in the red and the light blue, these mean the same. But I would strongly recommend, if you have something set up in this format on the SAT or any problem in general, is that you should set them back up into this form here. And this is why. Let me explain. The reason is, in order to solve for a type of problem, let's go back to this made-up marshmallow and oat cereal example here for our Lucky Charms. I feel like I'm going to get sued, so I should probably put, let's see, it's Lucky Charms, registered trademark, right? Put RT. Okay, hopefully keep the legal beagles off of me. But okay, but okay, supposing I had a problem like so. Let's suppose I said, all right, if the ratio of marshmallows to the oats is it's 2 ounces of marshmallows for every 6 ounces of oats, and supposing I had 12 ounces of the oats, of the cereal, how many marshmallows would I have? Okay, you probably can just do that in your head, but I want to show you how you set this up such that it's mathematically easy to solve whether or not the numbers are simple. Okay, so the step number 1, let's put step number 1, is write down the known ratio. All right, so the known ratio is this one in the green, right? We know it's 2 ounces of marshmallows for every 6 ounces of the cereal. So I'm just going to just write that down right here. Okay, So 2 ounces of marshmallows for every 6 ounces of cereal. Okay. Now, step number 2, set that equal to the new unknown ratio. Okay, so in my example I said we wanted to have 12 ounces of oat cereal, and I wanted to know how many marshmallows we have. Okay, so here's what we do. It's very important. First off, I announced I have 12 ounces of the oat cereal. So I need to match that up with the correct, in a sense, the variable here, right? So my 6C represents 6 ounces of cereal, so I want to put my 12C in the same spot. So far, so good. Okay? Then the next thing we're going to do is, because we don't know how many marshmallows matches with this, let's put this as some sort of, you can just, whatever variable we want. You can do X, you can do A, but just something to represent, we don't know what this is. Okay, so I'm going to just put A like that. Okay, so really, what we're dealing with here is, oh, I probably should have done A, because I think that's going to mess people up, but well, let me erase that. Let's just do the standard mathematical convention and put the thing that we don't know and we're trying to figure out, let's put that as X. Alright, well then now we know that it's 6 ounces of the cereal matches with the 12 ounces of cereal here, so then therefore what would match with 2 ounces of marshmallows? You probably can do that in your head, but here's the way that this works. You simply cross multiply the numbers. So it's just going to be, let's do as a brief review of cross multiplication. It's going to be this number here times that number here. So it's going to be 2 times 12. Well, that's 24, right? So just put equals 24. But it's those two numbers are going to be equal to these two numbers here. Let's put those in gray. 6 and this unknown number there. So it's going to be 6 times x, which is just 6x. Okay, so here's what we got. 24 has to be equal to 6x, and then to solve for this, solve for the x, right? How many ounces of marshmallows match up with 12 ounces of cereal? We would divide both sides by 6. So that really gets to x, the number of marshmallows we're looking for, ounces, is equal to 24 divided by 6. And that, of course, is equal to 4. So the number of marshmallows that would match to keep the same ratio with 12 ounces of cereal would be 4 ounces of marshmallows. And that should hopefully make sense, because if you think about it, look what we did here. We basically doubled the amount of original cereal we had, right? If we went from 6 ounces to 12 ounces, we doubled it, right? This new amount is twice as much as what the original ratio was. So it should make sense that we would double the amount of marshmallows as well. So that would end up giving us 4 ounces. More on this with practice problems, but hopefully this initial explanation makes sense.